Today we are going to study LCR circuit. Here LCR circuit is shown. This is the distance across which voltage VR. This is inductance across which voltage VL. And this is capacitance across which voltage VC. And if we write VR, so that will be I times R, and VL will be I times XL, and VC will be I times XC, where XL is 2 pi L XC equal to 1 upon 2 pi FC. Here, across resistance, current and voltage are in same phase. Across inductance, voltage leads current by pi by 2. Across capacitance, current leads voltage by pi by 2. And this is source voltage equal to E0 sine omega t. Here, the same thing is shown. This is voltage across inductor, this is voltage across capacitor. So if you observe, voltage across inductor is in this direction, voltage across capacitor is in this direction. So the same is shown here. This is voltage across resistor. So net voltage or resulting voltage is like this. This angle is phi, this angle is omega t. This is impedance triangle. So PQ represents XL minus XC, and SQ represents R, and this angle is 90 degrees. So Z will be square root of R square plus XL minus XC whole square. So let's write these things systematically. So V0 across resistance is equal to I0 R. We are considering peak value. V0 across inductor is equal to I0 times XL. V0 across capacitor is I0 times XC. Now, resultant voltage can be written as, here, suppose VL is greater than VC. So net voltage will be in this direction, that will be VL minus VC, and this is VR, they are at 90 degree. So resultant voltage E0 square will be VL minus VC whole square plus VR square. So suppose we take peak values, so I'm putting 0 here. So it will become I0 times XL minus XC whole square plus I0 square R square. So we can take out I0 square, then R square plus XL minus XC whole square will be left, which is E0 square. So from here we can find out E0. So E0 will be equal to I0 times square root of R square plus XL minus XC square, or I0 equal to E0 divided by root of R square plus XL minus XC whole square. Here, this term, root of R square plus XL minus XC whole square, is called impedance, that is Z. So Z equal to root of XL minus XC whole square plus R square. The same is represented here. XL minus XC is perpendicular and R is forming base, then Z equal to this much, root of XL minus XC square plus R square. This is called impedance triangle. From here, we can find tan phi, cos phi. If we find tan phi, that will be XL minus XC divided by R. And if we find cos phi, that will be R divided by Z. Now, Condition of resonance. So we have got the situation I0 equals E0 divided by root of R square plus XL minus XC whole square. So for resonance, XL minus XC must be 0 or XL equal to XC. So this is omega L equal to 1 upon omega C, or omega square equal to 1 upon LC, which gives omega equal to 1 upon root LC. This is resonant angular frequency, but omega equal to 2 pi f. So let's write it at FR 1 upon root LC, or FR will be 1 upon 2 pi root LC. This is resonant frequency. Now, different possibilities are there. Suppose, as I told you, this is VL, this is VC, this is VR. Three cases are possible. If VL is greater than VC, then VL minus VC, and this will be R. So in this case, the equation of current will be equal to I equal to I0 sine omega t minus pi, and when VL equal to VC, in that case, this term will be 0, then only VR will be left. In that case, current equation will be just I equal to I0 sine omega t. And suppose VC is larger than VL. So in that case, this will be VR, and in this direction, there will be VC minus VL. So current equation will be I equal to I0 sine omega t plus pi, because this time effect of capacitance will be larger. So current will lead voltage. Now let's understand these concepts by some examples. Question number 1. Determine the impedance of series LCR circuit if the reactance of C and L are 250 ohm and 220 ohm respectively, and R is given as 40 ohm. So let's write the information. Here, XC is given as 220 ohm, XL is given as, here, sorry, reactance of C is 250. So mistake, let's rectify it. So XC is 250 ohm and XL is 220 ohm, and resistance is given as 40 ohm. We have to find out impedance. Impedance Z is square root of R square plus XL minus XC whole square. So it will be equal to 50 square plus difference of the two. So this is 220, this is 250. So that is 30 square under root, which will give a root 2500, which will be 50 ohm. Now let's go to next question. Question number 2. A resistor of 50 ohm, an inductor of 20 upon pi Henry, and a capacitor of 5 upon pi microfarad are connected in series to an AC source of 230 volt 50 hertz supply. Find the current in the circuit. So let's write the information. R equal to 50 ohm, L equal to 20 upon pi Henry, and C equal to 5 upon pi into 10 to the power minus 6 farad, and ERMS is given as 230 volt, frequency is given as 50 hertz. So let's write the values. So XL is 2 pi FL. So 2 pi into F is 50 into 20 upon pi. So pi will cancel out, and then we will get 2000. Similarly, XC is equal to 1 upon 2 pi FC. We put the values 1 upon 2 pi into F is 50 into C is given as 5 upon pi into 10 to the power minus 6. So this will become again 2000. So we can find impedance Z equal to root of R square plus XL minus XC whole square. So root of R square. R square means 2500 plus this will give 0 because both XL and XC are equal. So 0. So we will get 50 ohm. Let's see next question. Next question says an inductor L equal to 0.4 Henry, a capacitor 10 microfarad, and resistor of 400 ohm are connected in a series to an AC source V equal to 40 sine 1000 T plus pi by 3 volt. Calculate impedance and peak value of current. So let's find out. We are given V equal to 40 sine 1000 T plus pi by 3. So we can say V0 is peak voltage 40 volt and omega equal to omega T. So omega equal to 1000 radian per second. So we can find XL. XL equal to omega C. So omega is 1000 and L is given 0.4. So this will give 400 ohm. Then we find XC, which is equal to 1 upon omega C. Omega is 1000 into C is 10 microfarad, 10 into 10 to the power minus 6. So that will give 100 ohm. And resistance is given as 400 ohm. So we can easily find impedance. So Z equal to root of R square plus XL minus XC whole square. So it will be equal to 400 square plus XL minus XC will give 300 square. So this will be root of 25. That is 500 ohm. Now we can find maximum current, peak current. E0 is V0 upon Z. So V0 is 40 and Z is 500. So that will be equal to 0.08 ampere. Let's see next question. A resistance of 2 ohm, a coil of inductance 0.01 Henry are connected with a capacitor and put across 200 volt 50 hertz supply. Calculate the capacitance of the circuit so that the circuit resonates. Resonate means XL equal to XC. The current and voltage across the capacitor at resonance. We have to check pi equal to 3. Okay, so let's write information. R is given as 2 ohm, L is 0.01 Henry, and VRMS is given as 200 volt. Frequency is 50 hertz. Now, if you remember, I told you for resonance XL equal to XC, that gives F equal to 1 upon 2 pi root LC, where F is a resonant frequency. So we have to find out C. What we do, we just square it. F square equal to 1 upon 4 pi square LC, or C will be equal to 1 upon 4 pi square F square L. We put the values. 1 upon 4 into pi is 3. So this is 9 into frequency square, that is 50 square, times L, inductor 0.05. So this will give 1 upon 900. So that can be converted as 0.0011 farad, or same can be written as 11 into 10 to the power minus 4 farad. Now we have to find out IRMS. IRMS is equal to, since Z will be equal to just R, because XL minus XC is 0 because it is resonating. So IRMS equal to VRMS divided by R. So VRMS is 200 and R is 2 ohm. So it will be 100 ampere. Sorry, 100 ampere. Then voltage across capacitance is I RMS into XC. XC. So IRMS is 100 and XC 1 upon 2 pi FC. So put the values. So 100 divided by 2 into 3 into frequency is 50 into capacitance is we have just got 11 into 10 power minus 4. If we simplify, so we will get it as VC equals 303 volt, which is our answer. Thank you for watching.